everyone. So I want to show you how to solve colorimetric problems. So in colorimetric problems, what you will need to use is two kinds of formula. One is this formula that I wrote here. Q is equal to mc delta T, where you have m as mass, C is the specific heat capacity of the given material, and delta T is the temperature difference. So which is T final minus T initial. So this formula gives you the total heat required to change n gram of material's temperature by delta T degree, because the definition of specific heat capacity, which in short is called to be specific heat, basically if you drop the capacity bar, is the quantity of heat needed to change 1 gram of material by 1 Celsius degree. So if C is for 1 gram and 1 Celsius change, then if you have m gram of that material, you need to multiply C with m, right? C is 1 gram. If you have m gram, then mc is m gram of material's temperature change for 1 Celsius. And if you want to change the temperature of the material by delta T degree instead of just 1 degree, then you need to multiply mc with delta T. So this formula that gives you total heat required to change m gram of material's temperature by delta T degree. So for water, for example, C, the specific heat capacity value is 1 calorie per gram Celsius. So it means basically if you take 1 gram of water and want to change its temperature by 1 Celsius, you will need to give 1 calorie of energy to it to increase temperature, or you will need to take 1 calorie of energy from it to decrease its temperature. And once again, because this is for 1 gram and for 1 Celsius, if you have m gram of water and if you want to change its temperature by delta T degree, then you need to multiply that C value with m, which is the mass, and delta T, which is the temperature difference. So I just draw here a temperature scale. So in Celsius scale, we have freezing point of water at 0 Celsius and boiling point of water 100 Celsius. These two numbers are important because those are the phase change points. Okay, so we're going to come back to this later, but it's an important thing to remember. Freezing point in Celsius scale is 0 degree and boiling point is 100 degree, because those 2 points are the points where water turns into solid ice, then or vice versa, and it also vaporizes by passing 100 degrees Celsius mark. So you need to know these values basically. So let's solve one simple problem about water itself without any phase change yet. So if you want to find the amount of energy needed to increase the temperature of 100 gram of water from 10 degrees Celsius to 60 degrees Celsius, again, the formula that was given was mc delta T, and from 10 degree to 60 degree, there is no phase change, so you can use this formula directly. So let me show the question here. So Q, the total heat you will need is mc delta T. So m is given as 100 gram. C of water is 1 calorie per gram per Celsius. And delta T is again T final minus T initial, so it's going to be 60 Celsius minus 10 Celsius, right? So when you do this calculation, you will get 5,000 calories. So if you want to increase temperature of water from 10 degree to 60 degree, as you can see, it absorbs a lot of energy. 5,000 calorie is the total energy you will basically need to give to 100 gram of water. And that's one of the reasons actually we use water as a coolant agent in cars, because it's, mostly free and abundant, and it also absorbs a huge amount of energy because its specific heat is a high number. If you compare this value with any metal, you will see it's huge. Metals generally have really low specific heat capacities because of that fact. They get hot very easily, whereas water is having the high specific heat capacity. It's hard to increase its temperature. It absorbs so much energy. So that's the reason that in coastal area cities, the temperature difference between night and day is not that much. Whereas if you don't have a huge body of water like lake or ocean kind of big body of water in like Arizona or interstates, you will have a huge amount of change of temperature from day to night because of the fact that basically huge body of water is going to be absorbing a lot of energy during the day, and it's going to be releasing that energy slowly during the night, moderating the temperature basically. So the night-day change of temperature is not so drastic in coastal cities. Anyways, going back to colorimetric questions. So this is a formula that we use when you don't have any phase change. So if you have a phase change from, let's say, -10° to +10°, what do? Then one thing you need to know is that specific heat capacity is specific for the phase. So seawater is 1, whereas sea ice is 0.1 calorie. So when there is a change of phase, the C value changes. So you cannot use one-step formula like this from going from -10° ice to +10° in water, something like that. Instead, what you do is you need to, let's say another example, if you have -10°, let's say T initial is -10° ice, you have, let's say again, M is 100 gram. What you do is going from -10° to 0° first. That's where ice can melt, right? This is the melting point. So you use the same formula, but this time it's MC ice because you have ice, delta T, right? So this is to increase the temperature of ice. Ice can be not just be 0°, it can be -10, -20, it can be lower temperatures, right? So you're going to take this Q, the total energy, you had 100 gram, and as I said, sea ice is 0.5 instead of 1 for water. Delta T is going to be, final temperature is going to be 0 minus, you started from -10. So this minus is going to make it positive, and it's going to tell you that this is the energy that you need to add to ice to increase the temperature. So this is going to be then 500 calorie. So this is the amount of energy that you take ice at -10° and turn it into 0° ice, right? It's still ice, it's just 0°. And now, in order to melt the ice, you need to use another kind of formula, which is M times L. So this is just melted, and ice melts at 0°, and it's going to stay at 0°. And this L is called latent heat fusion because it's from solid to liquid phase, and it is 80 calorie per gram. So latent heat of fusion is when you don't have any temperature change. There is no temperature change in latent heat stage. You just melt it. So it's going to turn into 0° water from 0° ice. And in this case, for melting, you need 100 times 80, 8,000 calorie of energy just to melt the ice at 0° temperature. So now you have total Q, where you increase the temperature of ice from -10 to 0° at 500. And also you melt it at 0° with 8,000 calorie. So you spend basically 500 calorie just to take ice from -10° and turn it into water at 0°. Okay. So and then you can increase its temperature to whatever the final temperature. Now it's water. When you add 500 calorie to -10° ice, it's going to basically be completely melted at 0° Celsius water. I hope this helps for at least some of these problems you have, and I'll try to make some other videos. Let me know if you have any questions. Have a good day.